that's your 8 protons and 8 neutrons. And then in the first energy ring, you have 2 electrons. And in your second energy ring with oxygen, you have 6 electrons. And then when you bond hydrogen to it, you have that single proton in the middle. And in that single ring, it's bonding with 1 electron. So those are all electrons. Which is what's called a chemical bond. So a chemical bond is formed to make atoms more stable. So what it's trying to do is fill out the outside energy ring to be completely full so that it is completely stable. So this wants to have 8 in its ring, so these ones donate that 1 on each to make it stable. And this ring now has 2 because it has that one connected with it.
How many of those can it have?
It's with water, this is just those 2 because that makes this outer ring stable for both of them. So that's why water forms.
So since it's H and then the 2 O, so it's 2 hydrogen and then 1 oxygen?
Yep, 2 hydrogen, those small ones up there, and 1 big oxygen right there.
Okay.
Yeah, so see how this one right here, so electrons don't stay in these rings like you look at them, they're moving all around. So these would be like flowing through this entire structure around the outside of it, and so that they're all stable.
So what kind of bond would this be called?
This is, let's see, an ionic bond.
Okay.
Oh, so this is the ionic bond.
No, never mind. Sorry, this is not an ionic bond. This is a covalent bond.
Okay.
Yeah, so they're sharing the outside and become stable. In an ionic bond, you have 2 chemicals that are opposite that hold together just with like the electricity in it, which is like what? Yeah, Na plus, K plus.
They're opposite.
Cl negative, yeah. Chlorine is negative.
Those are considered as one.
These are all the ionic bonds. So ionic bonds form what we call electrolytes.
Oh.
After they.
Thank you. Just plain English.
After they
I
break
understand
down, right?
electrolytes because I know potassium is one of the
Yes.
electrolytes.
Yeah, after they break
Potassium, sodium, what
This
else? Chloride.
Okay, so ionic bonds form electrolytes. So like if you have NaCl, that's table salt. That's just regular salt. And when you drop it into water and you mix it up, they actually separate from each other and they become an electrolyte. So electricity can pass through that. It's the same thing with like KCl,
So they dissolve in water? Is that what it is?
KCl.
water's a solvent.
Yeah, water's the solvent. They dissolve in the water. And they keep their bond only with the electricity, and that's why it's an electrolyte.
So off topic.
Yeah.
Or sort of on topic. So like just FYI, say like the one that says LR, what is that? Because they say that those are supposed like the fluids.
Oh, lactated ringer
Yeah, like
solution? Yeah, lactated ringer has a lot of stuff in it.
so that's like this basically where it has all of
no,
that.
only if it's lights. Only if it's electrolytes.
Okay.
So when people are getting those replenished IVs,
Mm-hmm.
they're just putting that stuff in.
They're just putting this stuff in, yeah.
And then they're waiting for it to break down so it can.
Yeah, it dissolves in your body and your body picks up what it needs and everything like that, so.
John is just saline.
Saline is NaCl, is sodium chloride in water.
I
And that's,
didn't know that.
yep,
Will we learn that later on or this is
you just did.
that's it? Okay.
No, IB class you learn a lot more about electrolytes and stuff, like we're getting the basic stuff real quick.
But what's the purpose in electrolytes?
It's for chemical, it's for electrical, like, it's moving electrical, like, energy so that it can, like, send information to your cells. So like when you talk about a neuron, you have your calcium channels and you have like your proton pumps and everything like that. Like everything moves just information.
Like especially in the heart, right?
Yes, especially in the heart.
That's what you do.
Let's see.
So the protons and the neutrons should be the same amount in the nucleus. That is, let's say there's three protons.
Oh, wait, no, I don't understand anything.
What?
I don't understand
They
anything.
break it down.
There's not going to be a ton of this stuff.
4 and 4.
Oh, but there's every time start it all?
Maybe.
Like 16 total.
Can you go over
I think he
again the
just-
nucleus part?
He just
The nucleus?
Yes, does it matter what, like, do they have to even each other out kind of
They
thing?
usually even each other out. Okay, so with protons and neutrons, there's usually an equal number unless it's like hydrogen, which is just a single proton.
Okay.
But if it has a different number of neutrons, it's actually a different, it's the same compound, but it's a different, like, isotope is what it's called.
Oh, yeah.
Yeah, so if you ever heard the word isotope, it means it's a different number of neutrons, but it's the same element.
Sounds like Chinese.
Yeah, I know, I agree.
It's like, I don't get it.
That's how you get like radiation or uranium.
Isotopes generally make them more radioactive, yes. But there are some stable non-radioactive, like, isotopes.
I'm gonna have to watch videos of this.
The water
Sounds
like-
redonkulous.
Okay, so, remember when we talked about CHON the other day?
Yeah.
The CHON.
Carbon, hydrogen,
Carbon,
oxygen,
hydrogen,
nitrogen.
oxygen, nitrogen, like the like
Four
main
major
constituent.
elements
Yeah.
that create
That's
atoms.
where the majority, 96%.
Yes. So like those are your major atoms for the body. Of course, H2O is the most important in your body.
Aqua.
Yes, agua, water. So water is what's called a solvent.
Water is that liquid stuff.
So water is what's called the universal solvent. Because most things dissolve in water. So because of that structure that I showed you, that atom that I drew, that special shape, water is what's called a polar molecule. There we go. A polar molecule. And because it's a polar molecule, it's kind of sticky. Like water has its own like electrical attraction by itself, so things tend to stick to water, and that's kind of what holds our body together. So you have all kinds of things that you can make with water, and it's in our body, like for most important stuff. But you have, let's see. Okay, so water is necessary for ATP. Yeah, which is the energy of the cell.
So it's just water, boats.
Water dissolves everything. Water, like that's why it's called the universal solvent, because everything dissolves in it, and then it makes an aqueous solution, so that things can be moved around easily. Things can become other compounds in water because they're dissolved in it. Like, see, and H2O is a really neat compound because it also can separate into H plus and OH negative.
What was that again?
See, so water, the H2O, can also be HOH.
evaporation, right?
Hmm?
From evaporation.
No, not from evaporation, just in like a solution of water.
Or you're talking about that pH scale thing?
Yeah, so this is where the pH scale comes in. Because water can dissociate into H and OH, and if it collects more of the H's from whatever it dissolves, it's acidic.
So H plus is acidic?
Yes, H plus is acidic. And OH negative, if that tends to go up, then that is basic. So pure water by itself has what's called a pH of 7. So water right here is pH 7. Okay? As the hydrogen molecules go up with whatever you dissolve it into, all the way up to 0. So it goes 0, 1, 2, 3, 4, 5, 6, and 7.
So the lower the number, the higher the acidity?
Yes, the lower the number, the more hydrogen atoms there are, and the more acid it is. And conversely, the opposite direction goes up to 8, 9, 10, 11, 12, 13, and 14.
Oh, so wait, it's alkaline, that's not.
So yes, this is alkaline.
Why do people drink alkaline water to balance out the acidity?
Because they have no idea what water actually does in your body.
Because we have some in our pantry.
Yeah, not necessary.
Oh, it's not.
No, absolutely useless.
So
the
some
higher
people
the-
buy, yeah, they buy the $3,000.
Yeah, it's super expensive and absolutely has nothing to do with anything.
So regular water is good.
Regular water is good for you.
It's like the best.
pH of 0 with the right number of electrolytes.
So,
So look at your little, there's a chart in there. Can you name off the stuff from right to left? Right here. You start off on the right.
Household ammonia.
Ammonia, right?
It's a cleaning product, isn't it?
That's it. Okay.
No.
We're talking about
10.5.
water.
No.
That's what I'm asking.
10.5 is MOM.
why is milk in the?
Pancreatic juice is at 8.
Oh, I thought you were reporting.
8.
And then at 7.8 semen.
I'm on my
Yep, so semen is, you said 7.8?
Yes.
And then at 7.4 is blood.
And 7.4
Blood.
is blood.
And then at 7.0 is cytokines.
So it's important to remember these numbers.
Hmm? I'm just saying, like, this is just so you guys can figure out, like, what normal things. Like, look, what's that number right there? What's it for blood?
7.4.
So it's barely alkaline, right? So why would being more alkaline be any better? It wouldn't. So let's start going on the acid side.
Yes, it's
At 6.0 is there's urine.
So yeah, urine,
And then
Then
at
at
5
5 is black coffee.
okay, coffee.
Oh, goodness.
vaginal secretion 4.1.
Uh-huh.
So that's why coffee is good for people with ulcers.
Oh, black
At
coffee.
2.8.
So now this is a fun one right here. See what this number is? Vaginal secretions are at a 4. Semen is at a 7.9, 7.9.
If a person is,
See,
they have ulcers, and say if somehow
Why
they
is that fun?
consume vaginal secretions, it's gonna burn?
No, because look at stomach acid on there.
Stomach acid is 0.8.
Oh.
0.8.
So 0.8, so all the way down here is stomach acid.
So that, anything lower than that is what's gonna affect. No, never mind.
No, so anything higher.
Anything
Right?
So taking alkaline water, something over here, and mixing it with your stomach acid means you are de-acidifying your stomach, which can cause a lot of problems. You won't be digesting your food right, you won't break down things the right way.
No wonder when.
So is apple cider vinegar okay to?
It won't hurt you, but it doesn't do anything better for you.
So
There's
those
no benefit
numbers
for
then?
So what would it mean if you take probiotics or whatever?
Probiotics,
That's
if
good.
they're not encapsulated, if they're not in something that keeps it from getting through the stomach acid, you just kill it.
So yogurt and stuff.
Yeah, yogurt and stuff like that, like a tiny portion of the probiotics actually pass through because your stomach has such strong acid,
It's gonna kill it.
it kills nearly everything. That's the point of having a stomach because it protects us.
So that like Yaka, whatever, those little drinks.
Yeah,
probiotics?
Colt, but they're just tasty,
So it-
Yeah.
They do absolutely nothing though.
other than give you calories, yes.
Oh, wow.
Because the doctors make it sound like, oh.
It's gonna help
If
you.
you're taking,
Probiotics are absolutely helpful at the right dose, which is a very high dose, and with the right protection of getting through the stomach in order to get down here where it needs to be.
So it's just lovely.
Hmm? Yes. It's all money.
No.
So, in your body, this serves as a lot of different protection mechanisms. And see, so stomach acids here, your vaginal secretions are acidic so that they're more protected by, because it kills off bacteria that can't live in an acidic environment. Plus, when you have the semen, it kills off most of the semen, because only the strong survive.
So if you have
Your son was the fastest swimmer.
I didn't know none of this.
Not always, but yes, that could be it. That's also why semen is slightly basic, because it neutralizes it so they can survive when they get through.
So in this case, higher pH would be the lower number? Like,
more acidic is a lower.
more acidic would be.
Yeah, the lower number,
So it would be 2 would be more acidic than 6?
yes, it's much more acidic than 6.
Okay.
Also, if you look at the pH scale, it's not a straight line. So 6 is 10 times more acidic than 7, 5 is 10 times more acidic than 6. It goes up exponentially.
And 0 is just acid.
What, hydrochloric or
acid,
sulfuric?
pure acid.
They sit around this area, yeah. So the pH, all it means is potential to absorb hydrogen on this
So
scale.
water, I mean hydrogen.
So yeah, so it's the potential of hydrogen. So if you have a lot of hydrogen, it can't absorb much hydrogen. If you have almost none, it can absorb a lot.
But we need hydrogen.
Yes.
That's one of our main things.
So what does it mean when you drink a lot of water? Where is your pH?
That's
at?
alkaline.
7?
Well, water is just 7,
So you're
which
just
your
gonna be
body is
at 7,
mostly
that's
at
your
7.
normal.
So we
Yeah.
And 6 to 7 means, what about if you're dehydrated, you're gonna be where?
Dehydration might not have anything to do with this.
No?
No.
Oh, okay.
So what is this alkaline water that's been lying to us this whole time supposed to be do?
Nothing. They make money off you. That's what it's supposed to be for.
What do they say it's for?
Well, we were drinking in like a 9 or 10 water from the water store, and it made us like feel bad.
Hmm?
You said pH and then potential.
Potential of hydrogen, yes, is what pH
Well,
means.
we were drinking like
She said,